हॅलो एव्हरीवन. सो आज आपण हाय परफॉर्मन्स कम्प्युटिंगचा 5th युनिट बघणार आहोत. सो इज अबाउट CUDA आर्किटेक्चर अँड हाऊ टू इम्प्लिमेंट CUDA C कोड्स. सो लेट्स गेट स्टार्टेड. हे फॉलोइंग टॉपिक्स आहे या युनिटमध्ये. सो लेट्स सी. So what is a GPU? This is most prominent question. So GPU is graphical processing unit, special type of processor that was designed to render and manipulate textures, originally designed for rendering games and other uh, operations that require highly parallelized operations. So games, machine learning. So where CPU falls short, GPU fills that position. The key difference between CPU and GPU is how many transistors are allocated to the processor compared to the memory. So in GPU, thousands of processors are. In CPU, the processors are maybe 4 core, or modern ones are 8 core, 16 core, and so on. GPU has thousands of cores allocated to its own memory. तिला VRAM म्हणतो, virtual RAM. So this is a comparison between CPU and GPU. So you can see key a single CPU has only a few amount of cores, so low compute density, complex control logic. Cache is large, optimized for serial operations. So हे comparison आपण multiple times observe केलं की CPU हा serial task करण्यासाठी, serial किंवा general purpose task करण्यासाठी CPU is preferable. It has low latency tolerance and newer CPUs have more parallelism. As I said की नवीन CPUs मध्ये 4 cores 8 cores असतात. But compared to GPU has high compute density. It has high computations per memory access. GPU हे parallel operations साठीच बनलेलं आहे. It has thousands of cores, small cores, but thousands of them. ALUs, that are arithmetic logical unit. So graphics, computer graphics, VFX, CGI are the best cases of parallelism because multiple things we have to do at the same time. So and त्याची pipelines पण deep असतात, high throughput, high latency tolerance, आणि new GPUs are becoming more like CPUs and new CPUs are becoming more like GPUs. So both of them are kind of becoming similar to each other, but GPUs are more favorable for parallel tasks. So why use a GPU? So while originally designed for graphical processing unit, architecture of GPU is suited for any application which perform many of the same simple tasks. So like machine learning, where we have to perform matrix operation multiple times, thousands of times, GPUs are essential. Or in games where we have to perform lots of small calculations at the same time, GPUs are preferred. So same simple task perform करण्यासाठी GPU is preferable, but same simple task in hundreds, thousands, or even millions in quantity. So in 2008, NVIDIA developed CUDA. We'll see in the next slide. The first general purpose API for interfacing with GPUs. This has made it easy to interface with GPU and take advantage of this type of computation. The figure on the right shows a typical workflow for code utilizing a GPU. The figure पुढे मी दाखवतो. When used correctly, GPU computing can provide a massive speed up. Massive means sometimes it even boasts like thousands of times better than CPU. So CUDA हा developer friendly platform API NVIDIA ने launch केला होता in 2008 for their GPU. Note करण्यासारखी गोष्ट ही आहे की CUDA only works on NVIDIA GPUs. ते त्यांचं proprietary API. It doesn't work on any other GPU. So Intelचा GPU, AMDचा GPU ह्याच्यावर CUDA चालत नाही. CUDA only works on NVIDIA GPU. So you can see how much of a performance gap is between simple Intel CPUs, which are below here, and the NVIDIA GPUs. So the point is pretty clear. So manufacturers of GPU, so NVIDIA has all of these GeForce, Quadro, Tegra, Tesla. These are all the architectures. आता RTX पण चालू आहे ray tracing वाला. Then you have Intel, AMD, S3 graphics and Matrox. The latter two are not that popular. Mostly हे three players आहे NVIDIA, Intel and AMD, in which NVIDIA is the leading company of GPUs. So GPU architecture. GPU hardware is radically different than CPU, as I said, and GPU hardware consists of number of key blocks. GPU हार्डवेअरमध्ये मेमरी असते, स्ट्रीमिंग मल्टीप्रोसेसर्स SM आणि स्ट्रीमिंग प्रोसेसर्स. These three are the components. So global memory, analogous to RAM in a CPU server, accessible by both GPU and CPU, currently up to 6 GB. But for higher end GPUs, it is at 48 GB. The max to max GPU घ्यायला गेलं तर. Currently set up to 177 gigabytes per second for Quadro and Tesla products. RTX series किंवा A100 series याच्यापेक्षा पण जास्त पॉवरफुल आहे. सो ग्लोबल मेमरी म्हणजे GPUची पण एक सेपरेट रॅम असते, वी कॉल इट VRAM. So it is accessible to both CPU and GPU. It is a global memory, so काही स्टोर करू शकतो आपण related to GPU. Streaming multiprocessors perform the actual computations. Each streaming multiprocessor has its own computations, control units, register, execution pipeline, and cache. Hence the multiprocessor सगळ्या गोष्टी आहेत त्याच्यात included. So this is our architecture. PCI through आपण connect करतो GPU ला actual system सोबत. Then we have global memory, buses, and streaming multiprocessors on this side, and streaming processors on this side. We can ignore this. कारण हल्ली बऱ्याच सिस्टम्समध्ये मल्टिपल GPU असतात. एक इंटिग्रेटेड GPU असतो आणि एक डेडिकेटेड GPU असतो. So for multiple GPUs, every GPU contains all of this. So connection, global memory, memory bus for connecting it to other things. So streaming multiprocessor in this and streaming processors right here. The inside streaming multiprocessor plus architecture असतो. So it also has access to global memory, large memory accessible by all threads, but has high latency, not ideal, but fair enough. त्याच्यानंतर caches, so ultra high speed memory shared by all SMs help reduce global memory access latency. त्याच्यानंतर L1 cache, faster than L2 cache, closer to SM, texture cache, constant cache, different types of cache. Then the streaming multiprocessor itself, the core computational unit, the main computational unit आहे तो जो स्ट्रीमिंग प्रोसेसर्सला parallel execute करतो. Each SM has register file, fast access memory. So hierarchy कशी decide करायची? Global memory slowest, then comes L2, then L1, and register is the fastest, but it has the least amount of capacity. So fast access memory for thread specific data, shared memory, low latency memory shared among threads. आणि सगळ्यात शेवटी येतो streaming processor units, group of streaming processors responsible for executing actual thread instructions. So diagram is quite simple. Global memory, L2 cache, then all these different type of cache, SM multiprocessor, and then we have register, right, shared memory, and all the processors. So now comes the main part, the gist of this unit. CUDA काय आहे? What is CUDA? So CUDA is an acronym, short form for Compute Unified Device Architecture, developed by NVIDIA. Parallel computing architecture developed by NVIDIA. Computing engine in a GPU. Asterisk. Note to self, only on NVIDIA GPUs. Because NVIDIA is a company who mostly rely on proprietary software. They don't like open source. Linux is not really fond of it. That's another topic. So CUDA can be accessible to software developers through industry standard programming languages. In our case, आपण C use करूया. CUDA gives developers access to instruction set and memory of the parallel computation elements in the GPUs. So GPU मधले core elements आणि hardware access आपल्याला देतो CUDA, while being accessible using existing programming language like C, C++. So GPU Programming Model हे लक्षात ठेवायची गोष्ट आहे. डिव्हाइस म्हणजे GPU, होस्ट म्हणजे CPU आणि कर्नल म्हणजे जो फंक्शन GPU वर रन होतो ऑन द डिव्हाइस. डिव्हाइस मीन्स GPU, host means CPU. So CPU and GPU, and GPU has multiple blocks, and each block has its own threads. So the kernel is executed as a grid of thread blocks. All threads share data memory space. A thread block is a batch of threads that can cooperate with each other by synchronizing their execution for hazard-free shared memory access, efficiently sharing data through a low latency shared memory. So two threads from different blocks cannot cooperate. So as we can see, eka block मध्ये multiple threads आहे. But if I have block 00 and block 11, then ह्याच्यातले threads आणि ह्याच्यातले threads cooperate नाही करू शकत. It has to be that same block आणि त्याची shared memory असते. एकदम मोठी global shared memory define केली सगळ्यांसाठी, then that possesses a security risk. So this is why it is implemented this way. CUDA kernels and threads. Parallel portions of an application are executed on the device as kernels. One kernel is executed at a time. Many threads execute each kernel. So आतापर्यंत जेवढं शिकलो आपण हाय परफॉर्मन्स कम्प्युटिंगमध्ये पॅरलल पोर्शन्स कशी करायचे ॲप्लिकेशनचे. सो ऑन डिव्हाइस, लेट्स रिवाइज व्हॉट इज डिव्हाइस. डिव्हाइस इज GPU. याच्यात खूप कन्फ्युजन होतं. So I am pointing this out again and again. Parallel portion of the application are executed on the device, that is GPU, as kernels. One kernel is executed at a time. Many threads execute each kernel. At a time, एक kernel multiple threads वर execute होतो. So the difference between CUDA and CPU threads. CUDA threads are extremely lightweight, very little creation overhead, instant switching, and CUDA uses thousands of threads to achieve efficiency. Multi-core CPUs can only use not one, few. So that's basically the gist of it. Basically, whenever we implement multi-threading or multiple threads in CPU, त्याचा एक overhead असतो त्या threadला बनवण्यासाठी. But since CUDA is highly optimized for thousands of threads, दर एक thread बनवायला जास्त memory लागत नाही. Those are very lightweight. So CUDA can implement thousands or millions of threads, but CPU can only create a few, depending on the number of cores. So if you have a 2-core CPU, then you can implement 4 threads at the same time. Just an example, things can vary. So now comes the fun part, introduction to CUDA C. So आता आपण actual programming इथून start करूया. So write and launch CUDA C, C++ kernels, manage GPU memory, manage communication and synchronization. So आधी terminology बघून घेऊ आपण. Host the CPU and its memory. Like I'm reminding you guys again and again. Host is the CPU and its memory. Device is the GPU and its memory. Because हे code मध्ये महत्वाचं असतं. So this is the simple processing flow. आपण आधी communicate करतो CPU सोबत. So copy input data. इकडे included नाही इथे. So first it comes to CPU. आपण CPU ला input data देतो. CPU चा डेटा आपण GPUच्या मेमरीमध्ये कॉपी करतो थ्रू PCI. मग GPU प्रोग्राम आपण लोड करतो आणि एक्झिक्यूट करतो GPU वरच. स्टार्टिंगला CPU ट्रान्सफर्स इट्स डेटा टू GPU and then GPU performs its computation, then the result is stored on GPU. मग GPUच्या मेमरीमधून आपण तो डेटा फेच करतो परत CPU मध्ये. So it's kind of a loop. CPU gives the data to GPU, GPU processes it, and then GPU stores the data, then CPU has to fetch the data from GPU. CPU, GPU, CPU, GPU. So start my CPU, gives data to GPU, GPU processes it, stores it in itself, and then CPU fetches that data. So this is a simple hello world program, standard C. The CUDAचा separate compiler आहे named as NVCC. त्याचा command पण असा आहे NVCC file name .cu. CUDAची separate extension पण आहे .cu unlike C or C++. So to run CUDA programs we need NVCC, and to run NVCC we need GPU. आता तुमच्याकडे GPU असेल तर well and good, but this thing is so heavy. I just tried to download its setup and the setup itself is 10 GB. So मी म्हटलो let's use an online platform for it. So luckily there is an online platform. It's named Lead GPU. So let's transition to it. Okay. So this is the URL leadgpu.com. आणि इकडे क्लाउडवर GPUs hosted आहे आणि इकडे आपण कोड राईट करून रन करू शकतो विदाउट एनी GPU ऑन आवर साइड. GPU ते प्रोव्हाइड करता वेरियस काइंड ऑफ GPUs ॲक्च्युली. सो RTX series, Titan series, GTX series, and so on. So let's start a basic function. एकदम basic hello world. So hash include stdio. Simple CJ program पण याच्यावर चालता. int main void printf hello IT, okay, hello world, and then return 0. Then we just click on run. In functional mode it compiles, then it executes, then we have our output hello world. Slash n टाकायला होता slash n. Okay, compiling, executing hello world. Okay, that's better. So that's how you can run your CUDA codes online. तुम्ही सेटअप करू शकता locally, but I found it quite tedious. इकडे लिंक पण दिली डॉक्युमेंटेशनची. For now this platform is enough. So that was a simple hello world program. That was basic C, not even C++. So आता आपण डिवाइस कोड करू दादा. डिवाइस इज GPU. So आपण बघितलं कर्नल्स असतात. कर्नल्स means the functions that run on the GPU. So we need to define a empty kernel. So these are the syntax. So global void, then the function name. So we are just giving my kernel void. CUDA C++ keyword global indicates a function that runs on the device. On the device means on the GPU from the host code. NVCC separates source code into host code, CPU code, and device components. So GPU, device functions, example my kernel, processed by NVIDIA compiler. Host functions, CPU functions are processed by standard compiler, GCC. So let's run this one too. Transition back to compiler. So global void demo. Yeah. आणि याला रन करायसाठी we just say function name, then 3 sets of angle brackets. then number of blocks and number of threads, then round brackets. Let's run it. Okay, yeah, that works fine. So code in this executes on the GPU, while standard code like this executes on the CPU. So that is basically it for simple programs. So triple angle brackets mark a call from host code to device code, also called a kernel launch. So those are the parameters. We'll see that in the next lecture. That is all required to run a function on the GPU. Any questions? If any, please comment. Try to resolve those as soon as possible. And thank you for watching. See you in the next one. Wait a minute, why aren't these here? Also, the PPT will be shared in the description. So yeah, thanks for watching. Please subscribe. We are really close to 1,000 subscribers. So see you in the next one.